quadratic function. Yay, right? Quadratic functions are always going to be in the form of ax squared plus bx plus c. Always. A cannot be equal to 0, because if A is equal to 0, then it's just linear. B could possibly be equal to 0, and C could be possibly equal to 0, but A cannot be. Okay? So when we go through and we want to work with the data, we want to know whether or not it's a linear relationship, quadratic relationship. How does it work? Because when we want to do the linear regression part, it asks, what kind of thing do we have to select? So that's why it's important for us to know what kind of a line we've got, or a graph that we've got. So would this really work well for a line? It's a curve, right? Pretty obviously it's a curve. So we're going to have to figure out something else to go and use for it. In this case, it's actually going to be, a nice little quadratic. So, remember playing with our transformations, right? Those are always fun. Make things bigger, make things smaller, wider, taller, shift around, all other happy stuff. We've done that before, so it's not that big of a deal. More often than not, we're not going to go through and graph using transformations. You're going to use the graphing calculator, you're going to plug it in, and you're going to go from there. Graphing with transformations, though, does kind of help get us to the point where we can go and identify specific things. Specifically, vertex, high point, low point, and so on and so forth. And of course, we got completing the square and all that other happy stuff, which you guys enjoy so much, don't you? Okay. Now, there are a couple of things that we want to make sure that we have. Okay? These little gems are nice. Put them down in your notes. Have them available for quick reference. If you want H, negative B over 2A. If you want K, then you do that. It makes life a lot easier when you have to come up with the vertex. And when you're dealing with parabola, any type of quadratic like this, knowing where that vertex is a real handy thing. Knowing vertex and your intercepts, you can do a lot of graphing with just that information. Okay, when you're looking at your transformation, H comma K, that's what it's going to be. Because if you remember, when we go back and we talk about doing a translation, moving it someplace else, where is it going to go? Well, that's always our H comma K. That's going to be the vertex, wherever it is. So this one here was moved down to negative 2 comma negative 3. So when I'm looking at this right down here, this is going to be my H comma K. I know that it's been moved that far. So when I look at the equation, remember it's always x minus and y minus. So if I take x minus negative 2, that gives me the x plus 2. And the minus 3 just goes back on the back side of it the way it's supposed to be. So I know that from this information, that's where my vertex is going to be. Now, do I want to go through and do the completing of the square and all that other happy stuff? No, there's got to be an easier way to do it. So the easy way is right there. You pull that information out, and we're able to go and calculate where the vertex is going to be very quickly on any given quadratic. In other words, this allows for us to not have to complete the square. If you have it in this particular form, you can translate it into this form through this. Unless you really enjoy completing the squares. Who here enjoys completing the square? I don't see very many hands up. So, unless you want to complete the square, here's this. Handy thing to have. Properties of the graph quadratic. Okay, vertex is always going to be at these things. Now, you will notice h is equal to negative b over 2a. Negative b over 2a. Now, if you've got that value, you can just as well plug that into the equation. It'll spit back out where your k is. Or, in this case, the other part of the variable where the vertex is. Okay? So, locating the vertex without graphing. Yes, you can go and slam this all into it. But the question is, does this open up or down? Well, if we use this idea that h is equal to negative b over 2a, what's b? 6. What's a? Negative 3. Well, that puts the h at 1. Now, where is that going to be? Okay. Plug that back in. And when we plugged it back in, and we figured out that it's going to be at 1 comma 4. So if the vertex is at 1 comma 4, which way does this thing open? It's either got to go up or it's got to go down. The one thing I always kind of like to take a look at, besides that, is where is the y-intercept? Where's the y-intercept? Y-intercept is when x is 0, right? So it goes through the y-axis at 1. The vertex of this thing is at 1 comma 4. So does that mean from that vertex to the y-intercept, do I have to move down or do I have to move up? Down. Because 1 comma 4, now mind you, I'm not drawing any of this out because we're playing with this in our minds. 1 comma 4 is up over here, right? And my y-intercept is below it. So that means it's going to have to open down towards it. Now that's generally what I like doing when I have to figure out which way this thing is open. Okay. Now it says the axis of the line of symmetry is at 1. Okay, that's nice to know. But also because a is equal to negative 3, I have a negative going on there. That means that it's going to be reflecting it, correct? It's not going to open up. It's going to force it to go down. Another way of taking it. So, x-intercepts and the quadratic function. Remember that wonderful little thing? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we worry about what's inside that radical. Well, if that radical is negative, does it work? No. So another thing that we can use to determine whether or not it even crosses the x-axis is this. If the discriminant, the b squared minus 4ac part, if that is greater than 0, it will cross twice on the x-axis. If it is equal to 0, it will only hit once. Now think about this. What happens if my discriminant would be 4? How many possible numbers are there to get a 4? Well, there's 2. With the square root of 4, we can either have 2 squared or negative 2 squared, correct? Okay, so I have 2 possibilities. But if I end up with a negative 4 there, number can I multiply to get to a negative 4? That are two that are exactly the same. You can't. Nothing squared is equal to negative 4 unless you want to go to 2i. And that's an imaginary number, and we're not going there because we're only dealing with the some reals. So if we get negative, that means it never crosses the x-axis. And that's kind of helpful because if we know that it has to be opening up. If it's above it, and if it's below it, it has to be opening down. If it's 0, I know that the vertex is going to be on the x-intercept someplace. Handy little things to have. By going through and knowing what these things are, gives us a ballpark idea of how to go through and graph it. So, if I take a look at what they've got here, our point was 1, 4 before, right? We've got our axis of symmetry at 1. We knew that the y-intercept was here. Well, that's 1 unit away, so I know that 2, 1 is also going to be a point. What about the discriminant? Well, the discriminant was, in this case, a positive value. So it's going to hit it twice. Where is it going to hit it twice at? That's where we use the quadratic formula. And at negative 0.15 and at 2.15, those will be the x-intercepts. So now I've got my points. I got enough points. I can graph this thing out and I know what it's going to look like. The interesting stuff is always going to be where does it cross an axis and where is its vertex. We want to always identify the interesting stuff. Let's see. That. Okay. Finding a quadratic function given its vertex and a given point. We need to have that vertex simply because that will give us the h and k bit. I need one other point on there so that if I've got h and k, I can plug in my value for x and y and solve for a. So, we've got that. Here they plugged in for the other coordinates, 0 and 3. They solved the a is equal to 2. So now I was able to go and put the a in, know where my h is, know where my k is. Now I realize that I'm going through this rather quickly. All of the things that we have done before apply. This is simply putting together all of the tools that we have in order to find this. Then you are going through and solving. You've got two options. You can complete the square and graph the function in stages using transformations. Always fun. Okay? Or, this takes a little bit more, but it avoids a lot of the nasty calculation that you end up having to deal with completing the square. Determine whether the parabola opens up or down. Determine the vertex. Determine the axis of symmetry. Well, the thing is, if you've got the vertex, you've got the axis of symmetry right then and there. For me, I identify the y-intercept. Where is the y-intercept in relation to that vertex? Once I've got that established, I also know what my third point is going to be. It's got to be symmetric to where the y-intercept is going. So I've got 3 points now. And that also answers the question for step 1. Does it open up or down? Well, we know that it's going to be opening up or down based upon A. If it's positive, it opens up. If it's negative, it opens down. We've got a lot of quick things here that we can deal with. I mean, steps 1 to 3 are like that. Okay? Very little calculation. They pull out the values, plug them in. X-intercepts are going to take a little bit more because you're going to have to go through the quadratic formula is the quickest and easiest thing for them. Okay? inverts every single time it's tried. And then you can determine additional points by using the other thing, draw those on graph. Whenever you're drawing a parabola, you want to make sure that you have at least 5 points. Vertexes are required, 2 on either side. That'll give you the general shape of it. And generally, the ones that are on either side you want to look for are going to be the y-intercept. That'll give you 1 by reflection, give you a third point. X-intercepts. Are these always going to be symmetric? Yes, they have to be. So if you find 1, you know where the axis of symmetry is, you've got the 5th one. So in reality, you're only really calculating out 4 things. And those calculations are really simple. Use that stuff there. There you go. So, I'm going to let you guys loose and let you pass.